Assalamualaikum warahmatullahi wabarakatuh, and hello to everyone. My name is Amir bin Ahmad from Group 2, and I'm here to present subtopic 7.1, which is Elementary Row Operation or ERO. ERO is an important method to find the inverse of a matrix and to solve the system of linear equations. The following notations will be used while applying ERO. I will be presenting about the first operation, which is interchange the ith row with the jth row of the matrix. This process is denoted as Ri interchange Rj. The first operation of ERO, as I stated just now, is interchanging two rows. So how do we interchange these two rows? First, we will need a matrix with at least two rows. For example, 2, 3, 6 and 4, 5, 2. This will be row 1 and this will be row 2. So how do we interchange? Interchange just means we will switch the places of R1 and R2. It will be 4, 5, 2 and 2, 3, 6 without adjusting any of their symbol. That's what we mean by interchanging two rows.
Good morning everyone, I'm Go Jinyu from Group 2. Today I will present about another two elementary row operations, which are multiply the I row of the matrix with the scalar k where k cannot be 0, and add the I row that is multiplied by the scalar h to the j row that has been multiplied by the scalar k where h and k cannot be 0. Now let's take a look for the examples using the elementary row operations that I mentioned just now. Now we have matrix A, 1, 2, 2, negative 1. Question 1. Perform negative 3b2 to the matrix A. This means we need to multiply every element in the second row with negative 3. Therefore, the element in the first row will remain the same, and the element in second rows we need to multiply with negative 3. So we get the final answer 1, 2, negative 6, positive 3. Question 2. Perform B1 plus negative 3B2 to the matrix A. This means we need to add the first row to the second row, which has been multiplied by negative 3. Therefore, we get 1 plus negative 3 times 2, 2 plus negative 3 times negative 1. The element in the second row will remain the same, which are 2 and negative 1. Then we get answer 1 minus 6 negative 5, 2 plus 3, 5. Second row remain the same, which are 2 and negative 1.
Hello, my name is Tongren Hao, and today I'm going to explain the applications of elementary row operations. Okay, so for example 7.1, given the matrix A, this one, perform the following operations consecutively. So we have to perform 1, 2, 3, 4, 5 operations. So let's start. Okay, matrix A is 2. Okay, so the first one, we're going to interchange the two rows. So the first one and the second one we interchange it. So 1, 2, 1, 2, 5, 3. Okay, so for the second one, it's B2 plus minus 2 b1. So b1 is 1, 2, and 1. So if we multiply by negative 2, we'll have negative 2, negative 4, negative 2. 1, 2, 1. So we'll write the rows that are not involved in the operations first, and we leave the one that is involved at the last. So b2 plus this. Okay, so 2 plus negative 2 is 0, 1, and then 1. Okay, next is b3 plus 3b1. Okay, so this time we're going to operate on b3, which is the third row. So we'll copy down the ones that are not involved first. 1, 2, 1, 0, 1, 1. Okay, so b1 is this one. So it's 1, 2, 1. 3b1 is 3, 6, and 3. So b3 plus 3b1, negative 3 plus 3, we get 0. 1 plus 6, we get 7. And 2 plus 3, we get 5. Okay. I'll write over here because there's not enough space. The next step, b3 plus negative 7b2. Okay, so the same thing, we'll copy down the rows that are not involved in this operation first. So it's 1, 2, 1, 0, 1, 1. Okay. b2, negative 7b2. So b2, we have 0, 1, and 1. So negative 7b2, we will have 0, negative 7, negative 7. And then we add b3 to this negative 7b2, we'll have 0, 0, negative 2. Okay, for the last one, negative 1 over 2 b3. So this operation is mainly focused on b3, so we can copy down the first two rows as stated, as mentioned before, and then we just times everything, multiply everything by negative 1 over 2. So b3 was 0, 0, negative 2. So if we multiply by negative 1 over 2, we get 0, 0, and 1. And then we just copy it into the matrix. Okay, so we have completed all the operations that was stated in the question. So this is how you apply the different operations into a matrix. And for the last part, if matrix A is transformed to matrix B by using ERO, which is elementary row operation. Okay, I'll just write it down. Matrix A transform to matrix B by using ERO. We can say that matrix A is an equivalent matrix to matrix B. Okay, equivalent matrix to matrix B. Okay, that's all for me. Further explanations on other examples will be presented by Group 3. And that's all. Thank you.